Hello everyone, in this video we will explore the topic 5.6 determining concavity of functions over their domains. I. Concavity. Consider the following function f of s equals 1 over s minus 1. Alright, so if we use the graphing calculator, we graph it, it's going to be something like this. This one is the rational function. Alright, so as you learn in AP calculus, the graph of f is concave down right here, right? Which means from negative infinity to 1, right? Where 1 is the vertical asymptote. And concave up is going to be from 1 to positive infinity, right? Keep in mind, if the graph looks like this, or half of this one, like this, the function is concave up, right? Or it looks like this, or half of that, something like this, is concave down, right? Definition of concavity. Let f be a differentiable function on an open interval I. The graph of f is concave upward on the interval I. If f prime of s is increasing on the interval and concave downward on the interval I, if f prime of f is decreasing on that interval, right? Now, test for concavity. Let f be a function whose second derivative exists on an open interval a, b. If f the program of s greater than 0 for all s in the open interval a, b, then the graph of f is concave upward on that interval, right? If f the program of s less than 0 for all s in the open interval a, b, then the graph of f is concave downward on the open interval a, b, right? Definition of a point of inflection. A point of inflection is an ordered pair where graph changes concavity, right? So which means if it changes from concave downward to upward, or upward to downward like this, right? So the point of inflection is to be somewhere right here, right? Now, the point of inflection theorem. If c f of c is a point of inflection of the graph of f, then either f the program of s equals 0 or f is not differentiable at s equals c, right? Let's take a look at the first example. Determine the open intervals on which each graph is concave upward or downward and say any points of inflection justify your answer. Question A. f of s equals s to the 4 minus 4s cubed. You need to take the first derivative and second derivative, right? So I have the first derivative f of s equals 4s cubed minus 12s squared, right? And the second derivative is going to be 12s squared minus 24s, right? Now you need to let the second derivative equals to 0, right? So you have 12s squared minus 24s equal to 0. And then you need to solve for s, right? So I have 12s, factor this one out, so it could be s minus 2 equal to 0. So then I have s equals 0, right? And s equals 2, right? Now I need to create the side charts, right? Negative infinity to positive infinity, right? Now I have two values right here, 0 and 2, right? I need to place 0 here and 2 here, right? Now I need to check the sign for f the program of s, right? So I need to pick a number within any intervals, right? So for example, I'm going to pick number 1 right here, right? Within the interval 0, 2, right? Substitute 1 for s back to the second derivative function right here. So then I have what? 12 minus 24, which is negative, right? So this guy is negative. Now you keep changing the sign because the 0 right here, they are half multiplicity, right? So you just change this one to positive, this one positive, right? Now go back to the theorem right here. The theorem says if f the program of s greater than 0 on the interval a, b, the program of s is concave upward, right? If at the program of s less than 0, the graph is concave downward, right? So I need to say that the function f of s is concave upward from negative infinity to 0 and from 2 to positive infinity, right? And concave downward from 0 to 2, right? And the function f of s has a point of inflection at s equal 0 and s equal 2, right? Because f the program of s changes sign as these two values, right? If you use the graphing calculator to graph this function and identify the point of inflection or concavity, it should be something like this, right here, right? Now let's move on to question B. F of s equals 6 over s squared plus 3. Now you do exactly the same thing, right? Now I need to rewrite f of s as 6 times s squared plus 3 power of negative 1, right? So I'm going to use the power rules, right? So I have f prime of s is going to be negative 6 times s squared plus 3 power of negative 2, right? And then times 2s, right? You need to use the formula u power of n prime is going to be n times u power of n minus 1 times u prime, right? So this guy turns out to be 2s, right? And it's going to be negative 12s times s plus 3 raised to the negative 2, right? You need to calculate the second derivative, right? So you need to use the product rule, right? So it can be u times v prime. It's going to be u prime v plus v prime u, right? So this guy turns out to be negative 12 times s squared plus 3 raised to the negative 2 plus v prime is going to be negative 2 to the front, right? Negative 2 and negative 12s becomes 24s, right? Times 2s and then times s squared plus 3 power negative 3, right? Now I need to combine this guy and this guy. 24 times 2 is going to be 48 and s times s to be s squared, right? So this one turns out to be 48s squared. Now I need to bring this one to fraction, right? So it could be negative 12 over s squared plus 3 squared plus 48 s squared over s squared plus 3 power 3, right? Now I need to rewrite this one in the same denominator, so I need to multiply the first one by s squared plus 3, right? So it turns out to be negative 12 times s squared plus 3 plus 48 s squared over s squared plus 3 all together cubed, right? Now I need to simplify the top, so I distribute negative 12, right? So it turns out to be negative 12 s squared, right? And negative 12 times 3 is going to be negative 36, right? Alright, now I need to simplify 48 subtract 12 is going to be 36, right? So this guy turns out to be 36 s squared. Alright, now I need to find the zeros of second derivative, right? So this guy turns out to be f the program of s equals 0 is the same thing as 36 s squared minus 36 equals 0. If you solve this one, s equals plus and minus 1, right? Now you need to find the value of s where f, the program of s, undefined, right? This guy undefined when denominator is 0, right? So you need to write f, the program of s, is undefined when s squared plus 3 equals 0, right? But this one always greater than 0, right? So there's no value of s, right? You're gonna create a side chart, -1 and 1, right? At the program of s always defined, right? So which means negative infinity to positive infinity, right? This guy are 2 0 of the at the program of s, right? Now you're gonna test value. So I'm gonna pick a number 2 right here. I substitute this guy into f the program of s, right? Which is right here. Then I'm gonna have a positive side, right? This guy positive, this guy should be negative, right? And this guy should be positive, right? So within the interval negative infinity to -1, the function LOS concave up, right? This guy concave up, and this interval concave down, right? And the function LOS has two inflection points at s equal -1 and 1, right? Because f, the program of s, changes sign as these two values, right? And if you graph it, it's gonna be something like this. Now let's move on to question C. We need to calculate the first derivative of f of s, right? And we need to use the quotient rule, right? So u over v prime is gonna be u prime v minus v prime u over v squared, right? So this guy turns out to be 2s times s squared minus 4, right? Minus 2s times s squared plus 1 over s squared minus 4 altogether squared. Now I need to simplify this one, so it will be 2s cubed, right? Minus 8s minus 2s cubed minus 2s, right? Over s squared minus 4 altogether squared, right? The numerator becomes negative 10s over s squared minus 4 altogether squared, right? Now second derivative is going to be quotient rule again, right? So it could be negative 10 times s squared minus 4 altogether squared, right? Minus over s squared minus 4 altogether power 4, right? Now I need to simplify this one. Negative 2s times 2 is going to be negative 4s times negative 10s is going to be plus 40s squared, right? So I have 40s squared right here. Now I need to factor s squared minus 4 out, right? So I have s squared minus 4 times negative 10 times s squared minus 4, right? Plus 40s squared, right? Over s squared minus 4 altogether power 4, right? Now this guy cancel out. Now I need to distribute this guy, right? So the numerator becomes 40s squared, subtract 10s squared, it could be 30s squared, right? Negative 10 times negative 4 is going to be plus 40, right? Over s squared minus 4 power 3, right? Now I need to let f, the program of s equals 0 is the same thing as 30s squared plus 40 equals 0, right? This equation has no solution, right? Because 30s squared plus 40 always greater than 0, right? Now you need to find the value of s where at the program of s undefined, right? So f the program of S is undefined when denominator equal to 0, which is s squared minus 4 equal to 0, right? And then s equals plus and minus 2, right? Alright, now you need to put this guy on the number line, right? So you have negative 2 right here, 2 right here. Now you need to check the sign of f, the program of s, right? So here is f, the program of s. Alright. Now you're gonna pick a value, right? So I'm gonna pick a 0 right here. I substitute into f, the program of s right here. The top is positive, the bottom is negative, right? Because 0 squared equals 0 minus 4, it's gonna be negative 4 power 3. It's gonna be negative, right? So this interval is negative. Then you keep changing the sign, positive e and positive e, right? Or you can pick a number right here. For example, I pick number 3. I substitute over here. It's gonna be positive, right? I pick a negative 3 right here. I substitute over here. It's gonna be positive, right? So you can conclude that f(s) is concave upward on the interval negative infinity to negative 2, right? And 2 to positive infinity seen at the program of s greater than 0 on those intervals, right? Now f(s) is concave that work on the interval negative 2 and 2 seen at the program of s less than 0 on that interval, right? Now f(s) has no points of inflection, right? Because f, the program of s equals 0 has no solution. Now if you graph the third function, it looks like this, right? Now let's move on to the next example. Let f be a function such that f, the program of s less than 0 for all s in the closed interval 2 and 3, which selected values of f of s shown in the table below. Which of the following must be true about f prime of 2.5? Alright, now since f, the program of s less than 0, it tells us that the function f of s is differentiable and continuous, right? And also f prime of s is decreasing, right? So we're going to use the mean value theorem, right? So the mean value theorem say if the function f of s is continuous on the closed interval a and b and differentiable on the open interval a and b, then you have f prime of c equals f of b minus f of a over b minus a, where c inside the interval a and b, right? So I'm gonna pick this interval 2.3 and 2.5, right? So I have the value of c between this interval. So I have f prime of c equals f of b, which means 4.38, right? Subtract f of a, which means 4.12, over b minus a, which is 2.5, subtract 2.3, right? And this guy turns out to be 0.26 divided by 0.2. It's going to be 1.3, right? Now, since the function f prime of s is decreasing, it tells us that if you have s1, s2, then f prime of s1 must be less than f prime of s2, right? So I'm gonna have c less than 2.5, right? Then f prime of c must be greater than f prime of 2.5, right? F prime of c is 1.3, right? So I have f prime of 2.5 less than 1.3, right? Now similarly, I'm gonna apply the mean value theorem one more time. This time I'm gonna pick the interval 2.5 and 2.7, right? So I have the value of c between 2.5 and 2.7, right? So f prime of c is f of 2.7, which is 4.6 minus 4.38 over 2.7 subtract 2.5. Alright, so it turns out to be 0.22 divided by 0.2. It's going to be 1.1, right? Now, since f prime of s is decreasing function, right? So if you have c greater than 2.5, right? This one right here. Then f prime of c must be less than f prime of 2.5, right? But f prime of c is 1.1, right? So I have 1.1 less than f prime of 2.5, right? Now I need to combine this guy and this guy. So finally I have 1.1 less than f prime of 2.5 less than 1.3, right? And the answer must be C. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand